Hey guys, so we're going to move on to a new chapter. We're going to move on to some trigonometry. And you may remember trig from geometry. Hopefully you do, and most students do, and they remember our magic word for trig that we use, which we'll get to in a minute. So today we're going to do how do we find sine, cosine, and tangent in a right triangle, and how do we determine exact value. So we're going to start off here with a nice triangle, a right triangle, and it says find the missing side. So we have a missing side here. So just a reminder, how do we find missing sides in right triangles when we know two sides? We use the Pythagorean theorem, right? Which is a squared plus b squared equals c squared, where c is the hypotenuse. So in this case, across from the right angle, 15 is the hypotenuse. And it also tells us find your answer in simplest radical form. So let's see, we get x squared plus 9 squared equals 15 squared. So you get x squared plus 81 equals, I think it's 225, but let's just be safe, right? So 15 squared, 225. And then we're going to solve this, so we're going to subtract 81. And we get 225 minus 81. Sorry, hold on. 144. So we get x squared equals 144. Take the square root of each side, and you get x equals 12. So no simplest radical form needed. You just get AC is 12. Now here, let's see, let's put our x here. The hypotenuse is 6, so you get 2 squared plus x squared equals 6 squared. So 4 plus x squared equals 36. X squared equals 32. And now when you take the square root, 32 is not a perfect square. But you get x equals, what are the two numbers that go into 32 that's a perfect square? 16 and 2, 4 rad 2. Okay, so just a reminder of how we do Pythagorean theorem and how we simplify radicals, both things we've done this year. So now we're going to look at trig functions. So we have theta. Theta, this is the symbol theta, and it's just a variable for angles, right? It's no different than x, but we just like to use theta for variables when we don't know an angle measure. And we have our magic word here, remember, SOHCAHTOA. And we like to sometimes write SOHCAHTOA a different way, right? We like to write it with the ratios being shown. And what does SOHCAHTOA mean? It means that sine is the ratio of the opposite side over the hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent, and there you go. So for example, in this picture, if theta is right here, and it's very important to recognize where theta is. Theta is there, so I like to label what side's what. The hypotenuse is always easiest. The opposite sign is the angle, the side opposite theta, and the adjacent side is the side touching that's not the hypotenuse, right? Two sides are touching, the blue and the pink line, but the blue is the hypotenuse, so the pink is adjacent. So here it says sine of theta. Well, sine is SOHCAHTOA. Sine is opposite over hypotenuse. So what's opposite? That's side CA. And what's the hypotenuse? That's BA. Cosine is adjacent over hypotenuse. Adjacent side of theta, BC, hypotenuse, BA. And then tan, let's get one more color here, let's do orange, is opposite over adjacent. Opposite theta, CA, and adjacent, BC. Okay? Now, we could try it with some numbers as well. Okay, I'm going to leave SOHCAHTOA on the screen up there, and it says, in the accompanying diagram, they label the sides and they tell you that angle B is a right angle. Find the sine of angle A. So what I like to do is make a little angle mark in the angle they're talking about. So now we can label everything. 17 is the hypotenuse because it's the longest side opposite the right angle. 15 is opposite the angle A, which we can call theta if you want. And then 8 is adjacent. So here we go. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, opposite, tan opposite over adjacent. So there you go. Okay, so we'll do one more problem here. might do two more. Find the missing side and then find the following trigonometric ratios. So here you go. We have a right triangle, but we only have two sides, so we'd like to use Pythagorean theorem. Let's call this is the hypotenuse. We can call it c, you can call it x, it doesn't matter. So now we get 2 squared plus 1 squared equals x squared. So 4 plus 1 equals x squared. 5 equals x squared. Take the square root, and you get x equals the square root of 5. It's not a perfect square, and you cannot simplify it. So let's just write, instead of x, get rid of that, I'm going to put rad 5. So now it tells us to find the trig ratios for two different angles. So this is going to get a little tricky. Let's do these three first, all talking about angle D. So if we're talking about angle D right here, then that means that, well, rad 5 is the hypotenuse. EF is opposite, right? It's across. And then adjacent is 2. So if we're talking about this, and I'm going to write my SOHCAHTOA up here. Here we go. So what is the sine of angle D? Opposite 1 over hypotenuse rad 5. Cosine adjacent 2 over hypotenuse rad 5. Tan opposite 1 over adjacent 2. And hopefully you start to remember this. Now, what happens if it tells us angle F? Sine of angle F, cosine of angle F, tan of angle F, then I'm going to have to change a few things. I'm going to erase hypotenuse, opposite. I'm going to start kind of fresh here. I'm going to leave rad 5 because that's still rad 5. But now if we're talking about angle F, well, 5 is the hypotenuse. Rad 5 is still the hypotenuse. But now what's opposite angle F? 2. And what's adjacent? 1. So sine now becomes opposite over hypotenuse, 2 over rad 5. Cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Okay? I think that's good for today. I think you guys can try that out, and we'll do some practice with it coming up.